Hello there, it's Hopman5000 with another AI update. So, let me drag over my notes. You can see that it's in the background. It got a reasonable score. You can see it's taking 5 minutes now to play a game, and I'm going to talk a little bit about that. So, I did manage to get Move 3 going, and that's been an interesting ride. There's all kinds of stuff that I've had to do as a result of it, and all kinds of problems that I had. So one of the problems was the heuristic of spreading out the board state was actually not very good when we got to move 3. It was keeping us from searching move 3s that were actually pretty good, because we were taking move 2s that were slightly lower positioned, and it was actually blocking a lot of moves that it shouldn't have. So the AI was very much improved by removing that. So move 3, because it's so slow, as you can see by the 300 seconds there, it has been causing me to look at all over the place for ways that I can start speeding it back up. So currently it's multi-threaded, though I don't have a good test to say whether the multi-threadedness is helping much or not. Let me think here. I started implementing various types of pruning, so it doesn't look at mirror moves anymore. That was mirror pieces, I should say. So pieces that are both the same type, it doesn't bother searching those, because that's very optimistic. I think I've talked about that pruning technique before. So anyway, we ignore those because they're why search moves for thousands of board states that are really easy to make. Just don't even worry about it. So we don't search those. We've been now pruning move 1, move 2 combos. So I started by pruning taking just the best moves from move 1 and then pruning down to those, and then searching move 2s, and then searching move 3s with the same pruning process. The problem was even though it played pretty well, that means that move 1 is really greedy, and being really greedy makes it so it doesn't necessarily cooperate with move 2, and sometimes you end up with garbage left over. So let me explain an example. So if you have 2 pieces ready to match, and one of your 2 pieces in your current move matches them, you could be greedy and just match them now. Or if your preview pieces also have another one of those, you could organize it so the preview piece gives you an extra empty space by combining all 4 of them rather than leaving that old piece still sitting around. So by doing move 1, move 2 combos and picking the best from those instead, now it'll do pretty nuanced moves like that in order to further minimize its board state. Again, you can look at the score there, 117, almost 118k. I'll run it again while I start talking here in a minute. I'm just a little worried that it's going to make the video low quality here. But one of the main issues with move 3 is that because it runs so slow, I can't really do statistical analysis on it. I'd have to run it all night, and running it all night and then running it all the next day, I've probably changed so much at that point that the statistics aren't going to mean much to me. So right now I'm still just trying to figure out how to speed it up enough to do much. So I've just kind of finished doing a lot of, I'll pull up some examples here, doing a lot of the type of thing where you do this, you bring out these self-references so it doesn't have to make as many sort of dereferences and then go find the thing and then bring it back, because C pieces is already a reference to what it's looking for. I believe it's supposed to run faster from what I understand about Python, although I could be wrong and I could just keep making this thing slower as I do things like that. But I did that through Gameboard, and I did that through most of Alchemy AI, and I pulled things out of loops that I could. As you can tell, a game now takes five minutes or so. Sometimes it's a couple minutes, So the next plan. There's two ways I've thought of dealing with this situation, and I'm going to test the easier one first. So the easier one is the one I'm going to tell you first, too. So the easier one is I'm going to take the find neighbors bit out of update grid and put it into its own function called run find neighbors. So that whole section of update grid will now just be a function call. Now, function calls are a little bit of overhead, but the hope here is that what I can do is use find neighbors wrapped in its new function and just call drop pieces and find neighbors for move 3. Now, this won't actually yield transforms, and so rather than measuring empty spaces, I'm hoping to re-implement the heuristic that says maximize matched pairings. And what I'll do with that information is say, okay, and then I'm going to square that result. So, so if you get two matches, or if you get a match of just 2 pieces, it'll be worth 4 points. If you get a match of 5 pieces, it'll be worth 25 points. So it'll still basically be trying to maximize empty space, but it's not going to go. It chops out the functions player lost. It chops out any piece generation or copying over or anything like that. It means that I don't need to call current board state to see what happened. I have to think about that for a second. But yeah, I believe I don't have to call current board state, and I don't have to analyze current board state or score it. And it means that I also don't have to perform any transforms or what I assume is a very slow operation at the end of that, where it refills the empties at the top of the list and then recombines a bunch of strings. So it should get rid of quite a lot of computation, especially since in move 3, that's a... alright. So, sorry about that. I had a solicitor call me, and I thought it might be somebody important, but it wasn't. Yay! So, we were talking about what we get to cut out with that heuristic, and I think it's probably going to be worth it because move 3 is that's a lot of moves. That's where we've already got potentially hundreds of thousands of moves, board states to check. So if we can, everything we can reduce out of there is thousands and thousands of those checks that we're not doing. Now, then the plan is I'm really trying to gun for move 4 because I think it's going to get us there. So then the plan will be to take the best one that has the most of those matches and actually perform the move, and then do the same thing that we did with move 3. So, at least, as long as we have multiple sets that maximize our matches, right? And so that means that we'll only search move 4 for this, like, really deep nuance stuff. And, so then the next consideration is whether or not to try and build a large dictionary, as it's called in Python, or a large hash table. And the idea with that would be that we store the current move position and the current board state as a hash. I have to figure out how to do that efficiently. And then store the subsequent board state on the other side of it. And what that would do is anytime we calculate a move 4 board state, we would store it, and then if it happens to be that move 3 next turn searches that same board state, now it doesn't have to perform the move. There are a few issues with this. First of all, move 4 is again several orders of magnitude larger than move 3. So we're really only trimming the easier stuff with the harder stuff. So, you know, the savings that we're getting on move 3 are nothing compared to the addition of move 4 when we get to it. So we really have to do a shit ton of trimming when it comes to move 3 in order to make move 4 viable at all. Which means, and the more trimming we do, the less likely we're actually going to have that hashed board state. So I'm not sure if that's worth implementing yet. But it's something to consider. So the first thing I'm going to do is try this weird refactoring bit where I chop out a whole bunch of the computation and try to estimate what the board state is going to be and see if that works out in my favor. And if it does, and I can get significant speed ups, then I can start actually focusing on move 4, and that'd be pretty sweet, because I'll run a game here real quick. But basically, if you look at how it's doing now, it tends to get over 100k reliably, and it gets a lot of runs that are 150k, 180k, and you know, some of that is down to some of that's down to luck, and some of it's down to it needs to search better. So the luck side of it is that, you know, at some point you're going to see that it really needs a couple piece types on the board, and then it would be totally clear. But it's not going to get those piece types, and if it did, which it still has the chance to, it would obviously perform better. So there is a bit of luck going into this, but also the farther we search down, oh, that's going to be awesome. That's beautiful. So the farther we search down, that's also really good. The more we're going to be predicting the right move to make now to maximize our chances of getting what we consider a good move. So I'm just going to keep babbling for a few minutes about this, what it's doing here, so we can get to the end of that, and then I'll let you go. So right now, the reason it's doing a lot of thinking is it has the move that it's previewing right now. It could stack the 8 on top here, or it could even put the 8 over here and it would get a similar board state. But it wouldn't have gotten the 9. And so by searching the move 2 and the move 3, it said, oh, I definitely want to get to that 9, because why not, right? Now this move 6, it has nothing to combine here. What are you blinking for? What are you doing? It has nothing to combine here, so it's searching everything and finding that it doesn't have any empty space to maximize. So then it searches everything again on the next level, and it's going to continue to find that it doesn't have anything to maximize, but what it's probably going to do is put those 6s near that 9 somewhere, because eventually it could actually it'll probably stick them next to the 5s, because the 5s could turn into a 6 later if it got the right moves. But it's hard to say. It might, you know, when you're thinking of thousands and thousands of board states, it's kind of hard to estimate what it's really going to do. Given that we're already at 10 moves, this is where we're at probably the 500,000 or so board states, and it's cutting out very few in this case. These giant, these are actually the ones I should try and figure out how to prune, because here in this case, there's no nuance, and so what's going on is it's searching something like 500,000 moves in order to find that really where it positions it doesn't matter much. And so what I should do is give it a secondary AI that says, oh, well, this is a worthless move. Do this thing to try and maximize what we can. So maybe I can tell it to throw it off to the side, or put it as close as it can to a thing that's similar to it. But otherwise, this is the type of move that I'm worried about for move 4, where you know, you add 3 more orders of magnitude to that, and now you're at 500 million moves that you have to search. If you remember, I was pretty happy about getting 38,000 board states a second. Even if you quadruple that, 500 million takes a very, very long time. So I guess this is one of the problems I have to solve on the horizon, is moves like that, where both move 1 and move 2 are very unhelpful in giving the AI any direction. I should just say, hey, look, if the whole thing is, you know, screwed, just don't do it. Just don't even bother searching at this point. Random that move, because your guess is as good as mine. But maybe what I'll do is have it try to put it near, you know, if it's a 6, put it near the 5s, kind of a thing. And maybe I can find a quick and easy way to calculate that. Or use, like I said, a secondary AI that instead of move 3, just goes back through move 1, move 2, and says, what's the board state really look like? How about I stick these 6s near the 5s, because the 5s could eventually be 6s. Or stick these 6s next to the 7s, if there was a 7 there, and whatever. And we'll just do the same thing with the 7. If we don't see any matches that we can possibly do, let's stick the 7 near the 6s, and we'll see what happens. That's about as good as I think you can do there. And given that, what's happening here is that, again, it's dodging every pruning technique, except for matched pieces. Yay. So maybe it's only 200 and something thousand board states that it's searching. But either way, God, this is taking a long time. Either way, this type of scenario is absolutely the worst, because it's searching every move 1, every move 2, and then it's saying, well, shit, let's search every move 3. And so, when it does that, you just have hundreds of thousands of board states to search through. I don't know if I'm going to keep babbling while it keeps doing this. This is making me very impatient, because I think this is a problem that I have to solve if I'm ever going to get back to running statistics on these things. And given that this is the worst case, and it's also not going to come up with a good move, making it possibly slightly dumber in order to not do things like this is probably worth the time. Because, honestly, if everything in move 2, if everything in the first 2 moves don't make any combos, why spend a whole bunch of time thinking about it? Just make a move so we can get to something where we can actually think again. So, I guess I gotta go figure that out too. So, cheers, and I'll see you in a few days.